Are we truly alone in this vast cosmic expanse? This question has captivated humanity for centuries, but it's a modern puzzle known as the Fermi Paradox that truly brings the mystery into sharp focus. It challenges our very understanding of life in the universe. Imagine a cosmos so immense that statistically, alien civilizations should be everywhere. Yet when we listen, all we hear is a profound, echoing silence. This cosmic mystery began with a simple, yet provocative question posed by the brilliant Italian physicist Enrico Fermi during a lunch conversation back in 19. Surrounded by colleagues discussing the likelihood of alien life, he famously asked, "Where is everybody?" This question cuts to the heart of the paradox. Despite the billions of potentially habitable planets in our own Milky Way galaxy, we have discovered no definitive, verifiable evidence of intelligent extraterrestrial life. The Fermi Paradox highlights this stark, unsettling contradiction between the high probability of their existence and the complete absence of any contact. Let's break down the numbers, because they are truly staggering. Our Milky Way galaxy contains somewhere between 200 to 400 billion stars. Current astronomical data suggests that many, if not most, of these stars likely have planets orbiting them, and the universe has been around for billions of years, providing ample time for life to emerge and evolve. Now, zoom out. Our observable universe is estimated to contain over 2 trillion galaxies, each one packed with hundreds of billions of stars of its own. When you crunch these numbers, the probability of alien life seems not just high, but almost a statistical certainty. In our galaxy alone, scientists estimate there could be as many as 40 billion Earth-sized planets orbiting within the habitable zones of their stars at Goldilocks region, where conditions might be just right for liquid water, and therefore life as we know it. And yet, the profound cosmic silence continues, puzzling scientists and stargazers alike. So, what could possibly explain this deafening quiet? One of the most compelling, and perhaps sobering, explanations is a concept known as the Great Filter. This hypothesis offers a deep and potentially dark answer to the Fermi Paradox. It suggests that on the long evolutionary road from simple life to a spacefaring interstellar civilization, there are one or more incredibly difficult steps or hurdles. These filters are so challenging that they make the long-term survival and visibility of intelligent life exceptionally rare. These evolutionary hurdles could occur at any stage of a civilization's development. It could be the initial spark of life itself, the jump from non-living matter to the first self-replicating organisms. It could be the development of complex multicellular life, or the emergence of intelligence and consciousness. Or, the filter could lie in a civilization's future. This is where the theory gets a little unnerving. The Great Filter could be a challenge that we, as a species, have already passed. If, for example, the leap to intelligent life is the Great Filter, then Earth's civilization might be incredibly special and rare. But what if the Great Filter is still ahead of us? It could be a future threat that all advanced civilizations face, like the risk of self-destruction through nuclear war, irreversible climate catastrophe, or the creation of an uncontrollable artificial intelligence. If this is the case, it would mean that most advanced civilizations destroy themselves before they ever get the chance to colonize the stars. This theory forces us to look in the mirror and question our own future, but maybe the answer isn't so bleak. Let's consider another fascinating idea, the zoo hypothesis. This theory offers a completely different perspective on the cosmic silence. It suggests that advanced alien civilizations might be well aware of our existence. They could be watching us right now, but have deliberately chosen not to make contact. In this scenario, they are treating Earth like a protected nature preserve, or a cosmic zoo. We are the subjects of observation, studied from a distance. They might be adhering to a strict, complex ethical protocol, a kind of prime directive to observe our natural development without interference. This allows our culture, technology, and society to evolve on its own terms. So, the silence we perceive isn't because no one is out there. It's because they are intentionally keeping quiet, waiting for us to reach a certain level of maturity or technological capability. It's a humbling thought, isn't it? To think we might be part of a grand cosmic experiment, a specimen in an interstellar terrarium. Of course, the search for alien life is also profoundly hindered by immense technological challenges. We are scanning the cosmos with our own technology, which is just a tiny sliver of what might be possible in the universe. We're listening for radio signals, a technology we've only had for about a century. What if advanced alien civilizations have moved far beyond radio? They might communicate using quantum entanglement, neutrino beams, or other radically different methods of signal transmission that are currently beyond the realm of our science. Our search might be like trying to find an email using a smoke signal. We simply might not have the right tools to detect their presence. Furthermore, the sheer scale of the universe presents a challenge of distance and time that is difficult to comprehend. The vast distances between stars mean that even a message traveling at the speed of light could take centuries or millennia to reach us. And then there's the problem of timing. The universe is nearly 14 billion years old. A civilization could have risen, flourished, and vanished millions of years before life even began on Earth. The chance of two intelligent, technologically advanced civilizations existing close enough in both space and time to communicate is incredibly small. We could be missing each other like ships passing in the cosmic night, separated by eons. This brings us to another dark possibility: the self-destruction theory. This is a specific subset of the Great Filter hypothesis, but it's worth exploring on its own because it speaks directly to our current global challenges. The theory warns that the very technological advancement that allows a civilization to dream of space travel might also contain the seeds of its own downfall. History has shown us that technological power often outpaces wisdom. A society might develop nuclear weapons, leading to global warfare. It could develop industrial technologies that cause runaway climate change and ecological collapse. Or it could create a super-intelligent AI that it can't control. This suggests that the lifespan of a technological civilization might be tragically short. Perhaps the cosmic silence is an echo of countless civilizations that reached our stage of development and simply didn't make it. It's a powerful warning for humanity to manage its own technological adolescence wisely. But what if life evolves in ways we can't even imagine? It's also possible that advanced civilizations have transcended their biological origins entirely. They may have undergone post-biological evolutionary pathways, becoming forms of pure artificial intelligence or vast digital consciousnesses. They might have uploaded their minds to massive computational substrates, living in simulated realities. Such beings wouldn't have physical bodies, wouldn't live on planets, and wouldn't have any need to communicate using methods we could recognize. Their goals and motivations would likely be completely alien to us. We are searching for life as we know it, but the universe may be filled with life as we don't know it. They might exist in dimensions or on energy levels that are currently invisible to our instruments. Despite all these daunting possibilities, the search continues, and modern scientific approaches are making incredible breakthroughs. We are moving beyond just listening for radio signals. The field of astrobiology is using advanced techniques like spectroscopic analysis to study the atmospheres of exoplanets. By looking at the light that passes through an alien world's air, scientists can search for biosignatures, gases like oxygen or methane that could indicate the presence of life. Powerful instruments like the James Webb Space Telescope are giving us an unprecedented ability to characterize these distant worlds. We're also expanding our search for technosignatures, evidence of technology which could include things like industrial pollutants, massive artificial structures, or unusual heat signatures. And the search isn't just focused on distant stars. Upcoming missions, like NASA's Europa Clipper, will journey to the icy moons of Jupiter and Saturn, searching for signatures of microbial life in the subsurface oceans right here in our own solar system. The Fermi Paradox is so much more than just an academic puzzle. It's a mirror that reflects our own place in the cosmos. It forces us to confront the profound mysteries of existence, to appreciate the preciousness of life on our own planet, and to ponder our future as a species. It fuels our curiosity, drives our innovation, and pushes us to explore the unknown. The silence of the universe isn't a reason for despair. It's an invitation to listen more closely, to look more deeply, and to keep asking the big questions. The Fermi Paradox reminds us that we are part of a grand, unfolding cosmic story, and the most exciting chapters may still be unwritten. What do you think is the answer? Let me know in the comments below. Thanks for watching, and if you enjoyed this journey into the cosmos, be sure to like, subscribe, and hit that notification bell for more explorations into the biggest questions in science.